Hello everyone, today in this video we'll be discussing the first module of analysis and design of algorithm, the fourth semester subject. In this module we have the following topics taken from the syllabus, but don't worry, these are not much topics because I'll be telling you what all you need to remember from the exam point of view so that easily you can score more than 80% marks. Make sure you watch this video till the end, and before starting please do like and subscribe. It helps me make more videos like this. If you have any questions or doubts you can contact me here. This is my Instagram ID _AFUU. Okay, so without wasting any more time, let's get started. The first topic is what is algorithm. Okay, in analysis, design and analysis of algorithms, you need to know what is an algorithm. Okay, so just imagine that you went to a marketplace and you want to buy something. Okay, you want to buy an apple. Okay, suppose that you want to buy an apple. Now, to buy an apple, you need money. Okay, what you will do with that money, you will give that money to the shopkeeper and tell the shopkeeper how much you want the apples. Okay, and the shopkeeper will weight the apples and then he will be giving it to you. Okay, and you will be buying that apple and coming back to the home. uh, in this situation, what all the steps you followed, that step if you note down, that is the algorithm for buying an apple. Okay, the way to solve a problem. Okay, algorithm is a sequence of unambiguous instructions for solving a problem. Okay, for obtaining a required output for any legitimate input in a finite amount of time, that is called as algorithm, or in any other words it will be an algorithm is the way of solving a problem. Okay, this is the graph, the flow chart which is given here. That is the problem is present here, and to solve the problem we need an algorithm. That algorithm will be provided to the computer, and based on the input the algorithm will be acted upon, and then we'll be getting an output. Okay, so this is the flow chart of the algorithm. Okay, an example we can consider is the Euclid's algorithm. Okay, it involves repeatedly applying the following equality. GCD means what? Greatest common divisor. If I give you two numbers, like for example if I give you 10 and 5, in between 10 and 5, which is the greatest common divisor? It is 5. Okay, because 5 divides both 10 and 5, and greater than 5 there is no number which divides both 10 and 5. Now if we have two numbers m and n, how can we calculate the GCD? Okay, we can calculate it using GCD is equal to GCD of n comma m mod n, means divide m by n, and what remainder you get, that remainder if you calculate the GCD between these two, that also will be the same answer as m and n. Okay, for example, if you calculate the GCD of 60 and 24, how we can do it? First we will write 60 and 24 here, then we will divide 60 by 24, we will get remainder 12. Then we will find out the GCD of 24 and 12. If we divide 24 and 12, we will get the value of remainder as 0. We will put here as 0, and we will be getting a value here. The GCD between any number and 0 is that same number. Okay, any number and 0, GCD will be the same number, so we will be getting 12 answer, and that 12 is also valid for 60 and 24. 12 is the greatest number which divides both 60 and 24. Okay, so the algorithm will be three steps, very simple. The first step is take n is equal to 0. Whenever we get as n is equal to 0, n means this value. Whenever we get this value as 0, whatever the value is present here, that will be our answer, GCD. If we don't get here 0, what we have to do? We have to divide m and n. Okay, and assign the value of n as the remainder. Right, divide m and n and assign the value of the remainder to r. Okay, means this place we'll be putting that remainder, and this place what we will be getting? We'll be getting the n value will be shifted to m value, so assign the value of n to m. Okay, and value of r to n, the remainder will be sitting here and the n value will be coming here. Okay, like that we'll be again repeating it. Okay, and again go to the step 1. This is the algorithm for it. Okay, and the same thing we can represent in the pseudocode also. Pseudocode means in coding language, how we will be going to do it, it will be written like this. Okay, it will not be specific to some language, it will be just an English. Okay, we will be writing the function name Euclid, and two parameters will accept m and n, and then we will compute the GCD by of m and n by Euclid's algorithm. Input is the two non-negative numbers, which is m and n, both should be positive, greater than 0, and output will be the greatest common divisor between m and n. How it works? While n is not equal to 0, till when we will continue? Until and unless we get this value as 0, because once we get this value as 0, this will be our answer. Till we get as 0, what we have to do? R will be m mod n, the remainder will be r, and m's value will become n value, and n's value will become r value. Right, that's what we are doing here. N is coming and sitting here, and r is coming and sitting here in n's place. So we will be finally returning m. When we will return m? Whenever this condition will become true. When this condition will become true? When n is equal to 0. When n is equal to 0 means 12 will be the remainder. That means m value is the GCD. Okay, Next topic is the fundamentals of algorithmic problem solving. To solve a problem, you need to create a flow chart. Okay, this is also very important from the exam point of view. Okay, this same flow chart you have to make, and for each point you have to write 2 to 3 key points that I'll be discussing. What key points you need to remember. Okay, so first is understand the problem, then find out 3 things on it. The first is the computational means, second is exact or approximate solution you want, and third is which algorithm you will be using. After you decide these 3 things, design that algorithm, then test if the algorithm is correct or not, then analyze the algorithm, finally code the algorithm. Okay, this is the flowchart you will be writing for the algorithmic analysis. Okay, algorithmic problem solving fundamentals. Okay, so totally 8 steps are there. The first one is understand the problem. In the problem, what all you need to understand? First is understand what is the input and what is the output you are seeing, what are the constraints present, what are the edge cases. Break down the problem into sub problems and clarify ambiguities, means whatever doubts is there, that should be clarified so that we'll be sure on what problem we are solving. Okay, next is decide on computational means, which data structure and computational resources you are going to use. Exact versus approximate solving, if you are going to get an exact solution or you want an approximate solution, that is also fine, that you will decide. Then you will design the algorithmic technique, which algorithm you are using, brute force, divide conquer, dynamic programming, greedy. These all things we'll be discussing in the upcoming modules. Okay, next is design an algorithm. After you have decided which algorithm you'll use, design that algorithm with step-by-step logical procedure. Use flowcharts to understand it more better. Then prove the correctness using some mathematical induction to prove that the algorithm works and it is fine for larger inputs as well. Analyze the algorithm, how much time it will take, big O, big theta, big omega. These are also very important topics which I'll be discussing in this module. From the exam point of view, these are the short topics. Okay, then we'll consider the worst case, best case, average case also. This is also very important topic. Then we'll finally code the algorithm with in any programming language of our choice. Okay, now that was the thing you need to write for the flowchart and the 2 to 3 key points for each of these concepts. Okay, that is about the fundamentals of algorithmic problem solving. Next is analysis framework. Okay, there are 3 things you need to remember: worst case, best case, and average case. Now what are these cases? Worst, best, and average. Okay, let's take an example. You know the sequential search, right? Sequential search means, suppose you have these many numbers and you start from here and you want to search a number, for example 39. You'll check if this is 39 or not, then you'll check this, then you'll check this, so on until the end you will check. The way in which we are doing this is called a sequential search, because sequentially we are checking each number. Okay, so worst case, best case, and average case will be how in this scenario. In this scenario we have to find out 39. If 39 is present at the end, in that case I will be the it will be the worst case. Why? Because I'll check this, then check this, then check this, till the end I will check, then I will get this. See how many checks have been done, how many resources were used, how much computational power has been used, and how much time was taken for each of these search. Then we finally got the answer. That is a worst case. Okay, more worse than this can't happen, the because this is the end point. Okay, this many is the maximum searches that can happen, and this was present here. So this is the worst case scenario. Best case scenario, first search only I got, this is the best case scenario. Average case means in somewhere in between it was there, not the best, not the last, in between somewhere. Okay, so the algorithm for sequential search is given here. We'll start from I is equal to 0 and we'll go till n. Okay, and whenever we don't get the value of key which we are trying to find out, we'll keep on continuing and doing I plus 1. Whenever we get the value, we'll be returning that value. In case we exceed the value of n and still we haven't got this one, we'll be returning it as -1. This is the algorithm for sequential search. Okay, now we have got 3 cases, right? Best case, worst case, and average case. Now for each of these case, representation needs to be done in the algorithmic form. So for that we'll be using some notation called as asymptotic notations. Okay, so for worst case we'll be using big O, and for best case we'll be using big omega, and for average case we'll be using big theta. Okay, what is these things we'll be discussing with an example. Now see, first you need to understand what is time complexity graph. Okay, time complexity graph means how much time it is taking for the number of inputs. See, if I give you one chocolate to eat, how much time you will take? 1 second. If I give you 10 chocolates to eat, how much time you will take? 10 seconds. If I give you 100 chocolates, 100 seconds. 1000 chocolates, 1000 seconds. As the number of inputs is increasing, the time is increasing, right? In the same way, in any algorithm, if you provide more input, more number of input, it will take more time. Okay, so that is the graph here which is given. This is the number of inputs. As it increases, the number of the time it takes also will increase. Now based on the algorithm, some will take very less time no matter how much is the input, some will take very large time no matter how much large is the input. Okay, so this differs based on the type of algorithm, and there are different types of algorithm. Okay, which take constant amount of time. Constant amount of time means even if 1,000 things are there, it will take the same amount of time it takes for just one thing. Okay, an example I can show you. If you suppose there is a dictionary, okay, dictionary is there, and for each number there is a letter. For one there is A, for two there is B, and so on. Okay, now in this dictionary, I want to find out what is 12 for. The 12 also will be written somewhere. I'll just have to look up for 12 and find out the answer. Directly I can access 12 and find out the answer. Even if I have 1012, okay, 1012, that also directly I can go to the index 1012 and find out the answer. So no matter how many inputs are there, I'm getting a constant time. The output I'm getting in constant time. That is O of 1. That's why the number of elements, as much as it is increased, the time taken is still as minimum. Okay, next is O of n. O of n is like a for loop. Okay, you can take it as for loop. The number of inputs, it increases linearly. Means the more number of inputs are there, that many iterations will be there, that much time it will take. If 10 inputs are there, it will run for 10 times, right? If 100 are there, it will run for 100 times. The time will also be increased 100 times. If it is 1000 means it will run 1000 times. The time will increase 1000 times if 1000 inputs are there. That is O of n. Okay, next is O of n square. Okay, O of n log n is also there. That is also a type of algorithm where this is the time complexity. It will take time increasing in the order of n log n. Next is n square. Okay, n square means what? If you have 10 inputs, how much time this for loop will run? If you have n value as 10, I will run from 0 to 10, and j will also run from 0 to 10 each time for I value. When I is 0, this will run 10 times. When I is 1, this will run 10 times. When I is 2, this will run 10 times. So for 10 times, it is running each 10 times. Means 100 times it is totally running this thing. The whole code runs 100 times here, right? 10 times into 10 times here, right? Here only one 10 time was there. 10 means 10 time it will run. Here 10 means 100 time it will run. That is n square. Okay, whatever is the input, that square time it will run. The square will be the amount of time it takes. So that's why, see, as you can see, that graph is very high here, because the n value is small only, but time will be taken more. N value is small only here, but time will be taken more because it is n square time is taking. Here it is equivalent is n only. Here n time is taking, here n square time is taking. Okay, so that's why this is a horrible one, because it is taking more time. The lesser the time the algorithm takes, the faster it is and excellent it is. The more time it takes, it is more horrible one. Okay, if you go further in the graph behind, we'll be getting exponential terms like factorial and exponential terms here. Like exponential example I can explain you. Fibonacci series. In Fibonacci series, for n input, we'll be calculating n is equal to n minus 1 plus n minus 2. Okay, what is the previous two elements we'll add, and we'll get this value. And what is n minus 1? N minus 1 is nothing but n minus 1 minus 1 and n minus 1 plus 1. Okay, these things means each value is calculated from the two other values, and this value is calculated from two other values, this also from two other values. So 1 is becoming 2 times, 2 is called 4 times, and 4 is called 8 times, 8 is called 16 times, and so on. It is increasing exponentially, right? It is increasing exponentially, and exponential is more larger than square value. Okay, why? Because see, if n value is 1, 2 power 1 will be 2 only, 2 power 2 will be 4, 2 power 3 will be 8. See, 2, 4, 8, 16, 32, and so on. But if it is n square, okay, if it is n square means what will be the value? N square means if it is 1 square is 1 only, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. See, it came till 25 here. But if we had put 2 power 5, if it was exponential, 2 power 5 is nothing but 32 or 64, right? So it is more, right? So exponential values will be more. So this is an example for the exponential value 2 power n. Okay, so the algorithms are divided into these parts. Now after you have understood this thing, based on this, some things will take worst time, some things will take best time, and some things will take average case. Let's take the first one and understand with an example what is the worst case scenario. Okay, now see, worst case scenario is written as big O. Okay, it's denoted as that. Okay, let g of n be a function, like for example a for loop. Okay, for example g of n I'm noting denoting for a for loop which is running for n times. Okay, a for loop which is running for I is equal to 0 to n, and each time it is, for example, printing Afnan. Okay, it is printing what? It is printing Afnan. Okay, so it is printing n times Afnan. How much n value I give, that much time it will print Afnan. Okay, so how much time it takes for that execution of that n time printing, that is the g of n function. Okay, and as the n value increases, time will increase because the more inputs has to be outputted, the more time it will take, the more number of inputs are there. Lesser inputs, less time, because less outputs are there. Got the point? So this is the graph. Okay, suppose it increases like this. This is the time graph for O of g of n. Now what is the worst case means? Worst case means if I get any other function. Okay, any other function, it's printing your name. For example, your name is just two letters AB. Okay, my name has 5 letters AFNAN, your name has only 2 letters, so this will print faster. Okay, so if this prints faster, this time graph will be little lesser, right? It will still increase with the number of inputs, how much time it has to print, but for each time it is taking lesser time than mine, so that's why this time is also less here. For each case it will be less. So that new function I'll call as T of n. Okay, now the new function I'll call as T of n. Okay, every function T of n, okay, listen carefully, every function T of n that has the time duration less than that of g of n, for every name smaller than mine, has lesser time to execute than my name, right? It belongs to the O of g of n, means worst case of g of n. Okay, means O of n is taken, O of g of n is taken as worst case here. Okay, this is the worst case, means maximum time it could take. Other all name which are smaller than mine have the time under this one. Okay, whatever the time comes under this one, that will be the worst case scenario. Okay, means this is the worst case scenario, and below that all are the better ones. Okay, like that. So worst case scenario is defined here. Okay, and the below ones are the better ones. So this thing is called as the big O notation. Okay, see, this one takes this much time, and if I have a function which is taking more time than this one in any other scenario, okay, no matter what the scenario is, this name will never cross this one because it has lesser letters, it will print faster. In no point of time, no matter what is the input, this will never cross the actual one which you have taken here. Okay, in that case I can call it, this is under the worst case of this one. Okay, it will never cross the worst case of this one. Okay, it is below the worst case. Okay, so g of n nested for loop, for example, if it is a nested for loop, okay, O of n square, and T of n is a single for loop O of n. Okay, so O of n square will take more time, O of n will take lesser time. So O of n will take lesser time, O of n square will take more time. So T of n is executing faster, it's taking lesser time. G of n is executing later, which is taking more time. Okay, so if function is lesser than this one, means it is covered by the worst case scenario, right? This is covered by the worst case scenario of this one. Okay, so like that we can tell. So how you will read this one? T of n belongs to the big O notation of g of n. T of n belongs to big O notation of g of n, means g of n is the maximum limit it can reach, but it will never reach. Okay, means it is the maximum limit, and whatever is the time is taking for any number of n value, it will be lesser than this one. Okay, so this belongs to this. Okay, and also while considering a class or a function T of n, we have to ignore the constants. Okay, constants means we'll be having 2 and division and multiplication and addition. Okay, you have to ignore that. Okay, how we will ignore? We just have to see the n value. Okay, we just have to see the n value. N square, it is obvious here, it is n square only. If a function is given of the time as this one, n into n minus 1, if we expand this, it will become n square minus n. You have to take the maximum one, which is n square, and ignore the minus n and everything. Okay, n square is the maximum one, so this also is n square. Here n square plus n by 2, again n square is the maximum one, n square you will take. 4n into 3n, which is 12n square plus 8n divided by 6. So n square came here, that is the maximum one, we will take n square. All belong to the time class of n square, like that. Okay, if it is n means n plus 1000, n minus 1000 divided by 500, 7 into n, whatever you do, n is here, there is no n square, the maximum one is n. So in a big O, what we are trying to do is we are finding out what is the maximum worst case scenario we can reach, and that one we are assigning. This is the maximum worst case scenario I can reach, so I'll not cross this one, I'm sure of that. So this will come under this one. Okay, means this will never cross this one, so it can be taken into consideration under this one. Now suppose that I have n cube. Okay, n cube. If t of n is given me n cube, I cannot take here. Why? Because n cube will cross this value. Okay, n cube will take more time than this. Okay, if this is n cube, it will cross at some point, so I cannot take it under the worst case scenario, right? I cannot take n cube under the worst case scenario of n square, right? Because it will cross it. That is the big O notation. It will give you a maximum reach where you can go with that value. Got the point, right? That is the big O notation worst case scenario. Now best case scenario means no matter how much efficient I make T of n, it will never become lesser than G of n. Okay, it will never become lesser than G of n. For example, if T of n is O of n cube and g of n is n square. No matter what I do to this, what I put all the masala and everything, whatever I do, it will never become less time than n square. N square will always take less time. Okay, so in this scenario I can call it as t of n belongs to the best case of g of n. Okay, t of n belongs to best case of g of n. If you want to see the graph will be like this. Okay, this t of n, this is g of n. Okay, no matter what I do to this time will be never crossing this one, because this is n cube, this is n square. Got the point? Okay, that is a big omega notation. That's for the best case. Okay, next is big theta notation. Theta means that there is a worst case, there is a best case. In between, if you are there and you never cross beyond this or below this, both cases if you don't do, the function which is between this one is the big theta. Okay, big theta lies between two functions. Okay, constant multiplied by g of n and constant multiplied by g of n. If c1 is multiplied by g of n, it becomes the worst case. If c2 is multiplied by g of n, it becomes the best case, and t of n in between lies here only. That is the average. Okay, big theta notation. Got the point? So if in this case it is there, we can call t of n is belonging to the theta notation of g of n. Okay, and there's an important theorem, from very important from the exam point of view. Okay, they can directly ask you to write and prove this theorem. Okay, so what is the theorem? The theorem they'll give you in the exam, you just have to prove it. Okay, the theorem is that if t1 of n belongs to worst case of g of n, means that t1 of n will never cross the time taken by g1 of n, and t2 of n will never cross the time taken by g2 of n. Now if I add up the time taken by t1 and time taken by t2, that value will never cross the maximum value of g1 and g2 of n. Okay, suppose g1 takes 10 seconds, g2 takes 20 seconds, and n1 takes 9 seconds, and t2 takes 11 seconds. So 9 plus 11 is what? 20. Okay, 20. And maximum of g1 and g2 of n, what is the maximum between these two? Maximum is 20, right? So 20. So 20 here also I got as 20. Okay, I'm taking very rough example. It can also break by, because if I take it as 12 here, 12 plus 9, it will become 21. Okay, I'm just giving an example. Okay, it does not work like numerics here. I'm just giving an example. The classes in which it works, how much time it takes. Here also another class is there, how much time it takes. T2 and T1 takes lesser than those two classes. If you add up T1 and T2, we'll be getting an answer that will be lesser than the class belonging to this value. Okay, means the maximum of G1 and G2, whatever is there, if we take that, it will belong to this class. Belong doesn't means lesser. Okay, because we are ignoring constant. 2 into n is considered equal to n in the algorithms. Okay, so you can't take it as different. It is same only because n is the thing which is considered here. That is the thing here. Okay, so we have to prove this one. Now see, we'll take two numbers a1 and b1, then we'll take a2 and b2. Now a1 is lesser than b1 and a2 is lesser than b2, then a1 plus a2 will be lesser than maximum of b1 and b2. Got the point? Now see, t1 belongs to o of g1 of n. We'll be writing the same thing here. We'll write it as follows: t1 of n is lesser than c1 into g1 of n. C1 is a constant multiplied by with g1 of n, and c2 is another constant multiplied with g2 of n. Got the point here? T1 less than or equal to c1 g1 of n, t2 lesser than or equal to c2 g2 of n. Now let's take c3 as maximum value of c1 and c2. Among c1 and c2, whichever is maximum, that I will take as c3. Now we will consider the maximum of n1 and n2. Okay, now t1n plus t2n, if you add up these two, we'll have to add up these two as well. So when you add up these two, what we'll get? C1 g1 of n plus c2 g2 of n. Then what is c1 g1 of n? We can take the maximum value here, right? So we have considered the maximum value of c1 and c2 as c3. So even if we take c3 here, here also we'll take as c3. Whatever is the maximum value, we'll take in both cases same, and we'll take it as common. We'll get g1n plus g2n. Okay, whatever is the maximum among these two, we'll be taking it here. Okay, now c3 into g1 of n plus g2 of n. Okay, maximum among g1 and g2 of n multiplied by 2. That same answer we will be getting. So the addition of these two is lesser than or equal to c3 into 2 times max of g1n into g2 of n. Okay, so therefore we can safely conclude that the addition of these two times, how much time it takes, that belongs to the maximum value of g1 and g2 of n after taking c3 as outside and ignoring the two constant. Just write this this formula, I mean the derivation, 2 to 3 times, and it will stay in your mind. Okay, don't miss this one. This is very important from exam point of view. Okay, finally you have to write this one. Okay, this line. Next topic. Mathematical analysis. Okay, here two things are there. First is for non-recursive, second is for recursive. Okay, both are very important. They can directly ask you the steps. Okay, what all questions can be asked in exam? Either they can ask you non-recursive or you can ask you recursive. Okay, for both mathematical analysis you need to know. And inside each of these mathematical analysis, two things are there. Okay, first is the steps for it. There are 5 steps for mathematical analysis for non-recursive, and for recursive another 5 steps are there. Okay, the steps you need to remember. Okay, and they can ask you the steps or they can ask you an example. Okay, few very much asked examples are there. Most asked examples that I've discussed, I've written here. We'll discuss each of these one by one, but before that you need to understand what is the non-recursive algorithm. Non-recursive algorithm means we are not calling the same function again and again. It is just a for loop. Okay, for loop, it will run for some time, it will get over. Okay, or another nested for loop, it will run for n number of times and over. Recursive means what? A function is defined and that function is called again from here. Okay, again this function will be called with a different value, and again that will be processed, and with a different value again it will be called. This example you can take as factorial and Fibonacci series. Okay, there we want to calculate the Fibonacci of n minus 1, then Fibonacci of n minus 2, Fibonacci of n minus 3, like that, and factorial of n minus 1, n minus 2, n minus 3. All those are recursive. Non-recursive, it will just have a loop. Okay, these steps will come at the end, before after we discuss the examples, because if you discuss the example, if we discuss the example first, it will be easier for you. Okay, so finding the largest element is the example number 1. In exam they can ask you, find out the mathematical analysis for non-recursive algorithm with largest element in a list of n numbers as example. Okay, this is also very much repeated question. Okay, so understand what we have to do. First, write the algorithm here. Okay, what is the maximum element? There is a set of numbers given. Okay, in this set of numbers you have to find out which is the largest number. So what is the input? An array 0 to n minus 1 of real numbers. Output will be the largest number present in the whole array. Okay, so what we will do, we'll first take the first number as maximum number, then we will iterate from the first to end, and each time we will check, is the new element greater than the element which we had considered as maximum? If the new element is greater, assign the new element as maximum value. Okay, and after this thing is done, at the end when we'll reach, we'll have find out the maximum value among the whole array. Okay, so this is the algorithm. Now how do you do the mathematical analysis? This is running a for loop. How much time it is running? 1 to n. Okay, don't consider minus 1 plus 1, nothing. 1 to n it is running, n time it is running, and each time it is performing some operation. So you'll be writing it like this. C of n means how much time it is taking, cost of n, cost of running this program. Okay, how much time it takes? It is running from 1 to n minus 1. 1 to n minus 1 means n time it is running, and each time it is performing a constant operation. Constant operation, why? Because a comparison will be taken a cost of 1, constant operation. So n times it is performing a constant operation. So what it means, n times it is performing constant operation means it is performing n times an operation, that is O of n it belongs to. Okay, and why we have written n minus 1 here? We have written n minus 1 because what we are doing here, n minus 1 minus 1 plus 1 we have to do. Okay, whatever is present in the upper limit minus lower limit plus 1, u minus l plus 1, this is the formula. So n minus 1 minus 1 is n minus 2, n minus 2 plus 1 is n minus 1, and n minus 1 minus 1 will ignore, it is of order n. Okay, this is how you analyze the time efficiency for the largest element, finding out the largest element. Next example, they can ask, check whether all elements are distinct or not. Means you have to check each element with each element. Okay, if suppose we have 5 elements, 1 2 3 4 5. Okay, what you have to check, 1 2 3 4 5, each element is distinct or not. Means one will be compared with 2, one will be compared with 3, one will be compared with 4, one will be compared with 5. If it is different, then 2 will be compared with 3, 2 will be compared with 4, 2 will be compared with 5, then 3 will be compared with 4 and 5, 4 will be compared with 5. Each element is compared with each element and checked if it is distinct or not. So here we need a nested for loop, right? First loop will run from 0 to n minus 2, second loop will run from I plus 1 to n minus 1, right? First it will run for 5 elements, next for 4 elements, 3 elements, 2 element, 1 element. So that's why it is n minus 1 here. Okay, and it will run till n minus 2. Okay, because n minus 2 is the second last element, n minus 1 is the last element. So here it will compare these two. The first loop should run till here, the inner loop should run till here. Okay, so it will compare these two elements at the end. So basically don't go into so much thinking, overthinking. Okay, here n is there, for loop is running n times, here also for loop is running n times, n into n is n square. Very simple, directly you can write n square. Okay, but if you like if they ask you to derive it, you have to write this whole thing. Okay, so don't worry what is this whole thing, it's very simple. See here, I is 0 to n minus 2, just write this sigma symbol here, 0 to n minus 2. Next is I plus 1 till n minus 1, right? So you will be writing I plus 1 till n minus 1. Now each time a constant operation is performed, it is the comparison operation. Okay, now minus this n minus 1 minus I plus 1 plus 1. Okay, n minus 1 upper limit minus lower limit plus 1. This answer we will be getting n minus 1 minus I, and then we will be just having n minus 2 and I minus 0, means this one we are substituting it with this one, means solving it. Okay, and this one also will do the same thing. So when we do this, n minus 2 and 0, so n minus 2 minus 0 plus 1 into this thing. Okay, because each time this is getting performed, so when you do that and simplify it, we'll be getting n square here. Okay, so n square is the time analysis for this one. Okay, checking if each element is distinct or not. The third example we can ask, which is also very important, which is the matrix multiplication. Okay, matrix means what? There will be n number of rows here, and each will have an element, and this is n number of columns will be there. When you multiply it, each row will be multiplied with each column value, and then an answer will be found out. Okay, that one we will be writing here. So for matrix multiplication, what we have to do? For matrix multiplication, we will be having to multiply two matrices. Okay, so each time this is multiplied with this, then this is multiplied with this is multiplied with this, and after we do the whole row with whole column, it will get added up and that will be written here. Okay, that is for one operation. Second operation will be second row with all of this, third row with all of this, fourth row with all of this, fifth row with all of this. So nested for loop came just for one column. Like that, again all the rows will be repeated for the second column, all rows will be repeated for third column. Each time n square n square n square n square is taken. So n square n number of times is nothing but n cube, right? Simply you can write it as directly n cube, but you need to derive it, so it will be very simple here. Each time n minus 1 is happening, n minus 1 n minus 1 times it is happening. So n minus 1 minus 0 plus 1, it will be n. So each time we will be multiplying n. This, if you simplify again, n you will get n into n is n square. This also will simplify again, n you will get here, n into n square is n cube. So you'll get finally as n cube here. Okay, and this is the code here. Triple for loop is there, n is here, n is here, and n is here, and constant thing is happening is some multiplication and addition, that is constant time. So n into n into n is n cube. This is how you find out the time analysis for non-recursive algorithms. Okay, now we will discuss what is the steps. Since you have understood the examples, the steps you can write by your own words. Okay, no need to memorize this one, and write it in your own words. The first thing is decide on parameter or parameters indicating the input size. What is the input we have taken? At each case we take the input as n. Done. Identify the algorithm's basic operation. In this, what is the basic operation? Checking this one. In the next one, what is the basic operation? Here also the checking and assigning it. Okay, checking here, not assigning. Here what is the main operation? Multiplying and adding and assigning. Okay, there is no checking here, just it is multiplying, adding and assigning. So the basic operation we need to calculate and find out what is the time taken for it. Usually it will be constant. Okay, after you have calculated how many parameters are there, then we have calculated how much time it's taking for the basic operation. Then we'll check how many times that operation is being called. Okay, if it is a single for loop, n time it will call, double for loop, n square time, triple for loop, n cube time. Find out that values, then express it as a sum, number of times the algorithm basic operation is executed. After that, use some formulas to simplify whatever is the mathematical analysis here. Okay, this is the formulas which is getting used. So these 5 steps you have to write. Okay, just write it in your own words, and if they ask the example, you have to write any of these examples as well. That was about the non-recursive one. Recursive one, again the steps are same here. Decide on parameters. Okay, how much input size is there? Is it n, n square, n cube? How much ever it is, take that into consideration. Then check what is the basic operation happening. Okay, and check how many times it is being called, and is it the worst case, average case, best case scenario. And if it is the recursive algorithm, the only step 4 will change. Set up a recurrence relation. Previous one was using mathematical induction, find out the sum and formula. Here it is set up a recurrence relation with appropriate initial condition for the number of times basic operation executed, and what is the least number of times it will be executed, and ascertain the order of growth of its solution. These two last steps will change, the first 3 steps will remain same. After you have written the steps, they can ask you any of the reconciliations. For example, we'll take the first one, factorial of a number. Okay, so factorial means what? If I say to calculate factorial of 5, factorial of 5 is 5 into 4 factorial. What is 4 factorial? 4 into 3 factorial. What is 3 factorial? 3 into 2 factorial. What is 2 factorial? 2 into 1 factorial, and 1 factorial is 1 only. what we basically did, 5 into another time we call the factorial, and what answer we got here, that one will be substituting and finding out another factorial. This one we got as 3 into 2 factorial, again we'll be calculating 1 factorial. So until we reach the base case, we are calculating it and keeping on calculating. So we are calling the same function factorial with a lesser value. 5 factorial means we'll call the same factorial function with 5 minus 1 4 factorial value, 5 into 4 factorial. 4 factorial will be called as 4 into 3 factorial, right? 5 into 4 into 3 factorial, 5 into 4 into 3 into 2 factorial, and so on. So n minus 1 factorial is being called at each time, and a constant operation, which is the multiplication, is being done. So constant time will be taken here. So t of n means if you want to find out the factorial of n value, you have to find out the factorial of n minus 1 and multiply it with n value. Okay. Factorial n, what is n factorial? N into n minus 1 factorial, right? This one only I discussed. 5 factorial is what? 5 into 4 factorial. N minus 1 is taken here. Now t of n represents the time number of operations to compute n factorial. N minus 1 means n minus 1 factorial. O of 1 means for the multiplication operation how much time it is taking. Now t of n is t of n minus 1 plus O of 1. Now instead of n, if I put here n minus 1, instead of this also it will become n minus 1, this will become n minus 1 minus 1, n minus 2. If n minus 1 is here, it is becoming n minus 2, right? N minus 1 means n minus 2. If n minus 2 I have taken, it will become n minus 3. Like that, if we keep on going, if this value become n, what will happen? T of 0, t of 0, it will become n minus n, and this will become t of 0 minus 1. I mean, if this one is the value n here, okay, if n value is here, this will be n minus 1, right? N minus 1 means n minus n plus 1, okay, means minus, if it goes inside, it will become minus n plus 1. So what is t of n minus 1 plus 1? T of n minus n is 0, 0 plus 1 is 1, so t of 1 it will become, right? If n value is present here, see, what I'm basically trying to say is, just assume 2, 3, 4, 5 we did, it become n value, n minus n is 0, okay, and whatever value we have got here, that value we used to substitute in this place, right? Like that only, whatever the value we have got is, suppose that n minus 1 value we have got here, n minus 1 value we substituted where? In this place. So like that only, when we substitute in this place, in that case what we will be getting is, if we put here as n value, this will become n plus 1, right? See, 2 means 3, so if you put n here, this will become n plus 1. So let's take n plus 1 here, okay. Now minus of n is minus n, and minus of minus 1 plus 1 is minus 1. So n minus n is, what is n minus n? N minus n is 0, and t of minus 1. T of minus 1 will be ignored, it will not be taken into consideration, so it will be a constant value. So basically at the end what we will get? At the end we will be getting O of 1, okay, and another O of 1 is here. That value will substitute again here. O of 1, this value will substitute here in the previous one, and 2 O of 1 will come and sit here. It will become 3 O of 1, 4 O of 1, 5 O of 1, 6 O of 1, until we reach the top. N times this happened, so n times O of 1 got executed. So n times if O of 1 got executed, that is nothing but n times it executed, it is the big O of n. Okay, this is the thing you need to write for the recursive one. Okay, next is the Tower of Hanoi. Okay, Tower of Hanoi you already know, in the third sem we have studied. In Tower of Hanoi what we'll do, we'll shift the disks from here to other place, okay, and the disk we have to shift it such a way that small disk cannot be at the bottom and the large disk at the top. Like this it cannot happen, large disk then small disk, okay. So basically that is the thing, but the main point is here how we will write the mathematical analysis, okay. So basically this is the steps given here, again go through it. The recursive breakdown is the most important, remember this one. T of n is 2t n minus 1 plus O of n, because 2 times we are moving the disks, okay, because moving for n minus disks twice, we are moving each disk twice, so 2 times t of n minus 1, and O of 1 is the moving of the largest disk, okay. Now mathematical analysis will be like this. T of n is this one, just substitute in n value n minus 1. If you put n value as n minus 1 here, what it will become? N minus 1 minus 1, that is n minus 2, so this will become n minus 2. 2 times t of n minus 2 plus 1, right? If you put n value as n minus 1, we'll get 2 times t of n minus 2, n minus 2, n minus 3 we'll get here. Like that till n will, if we'll go, what we'll be getting? N minus n, it will become 0, this will become minus 1, we'll not consider that, so we'll just consider n minus 1 till n minus 1, okay. If you put here as n minus 1, what it will become? N minus n, 0 minus minus plus 1, t of 1. T of 1 is the base case we are reaching, and t of 1 value is equal to 1, okay. So n minus 1 we have put here, right? So what is n minus 1 plus 1, okay, because whatever value put here, n minus 1 we put here, so plus 1 we will do and put here. So n minus 1 plus 1 is n value will be put here, this n minus n will become 0, t of 0 is constant, so it will be ignored, and 1 value we have got here. Like that 1 value will be substituted here, 1 plus 1, again it will become 1 plus 1, 1 plus 1, like that till the end it will go. And since from n minus 1 we have calculated, till end if we go, it will become n number of times minus 1, and each time it is taking exponential amount of time because 2 is getting multiplied here. So 2 times 2 power n minus 1. Okay, 2 power n minus 1, that will be taken into consideration. Okay, n times 2 is getting multiplied, so it will become 2 of n minus 1. This is the final thing you need to write, and this is exponential. Okay, if you actually do it and trace it, you'll get the same value. Okay, you can verify. I just told it from the top because this much writing in exam is sufficient for you. Okay, if you want to verify, you can substitute the values whichever I told. Like n minus 1, you can substitute here, and you here put n minus 1 plus 1, and you'll substitute the value back here until t of n when you reach, you'll get this value 2 of n minus 1. Okay, so for exam point of view, if you write this much and explain it, you'll be getting the full marks. Okay, this is the tower of Hanoi for recursive analysis. Let's take a third example which can also be asked in exam, very important. Here what you are going to do is, a positive decimal number is there, we are finding out its binary equivalent. Okay, means if number 5 is there, how can we find out the binary equivalent of this? 5 divided by 2, what is the remainder? 5 divided by 2, the remainder is 1. Okay, what is 5 divided by 2? The remainder is 1, quotient is 2. What is 2 divided by 2? 2 divided by 2 is 2 divided by 2 is 0, the remainder is 0, so we'll be writing here 0, and the quotient will be 1, right? So again 1 divided by 2, the remainder will be 1. So 101 is the equivalent of 5. Like that we'll be writing the reminders. So basically every time what we are doing, we are dividing by 2, right? So t of n will be t of n by 2 plus 1. Now if in n value you put n minus 2, so if you put n minus 2 here, n by 2 here, so this will become n by 2 by 2, which is n by 4. So t of n by 2 is nothing but t by n by 4 plus 1. Plus 1, already 1 was here, so it become 2. Now this value, when you substitute n by 4, n by 2 here, again we will get another 1 that will be added here, and this will become n by 8. So it keeps on going, right? And this is nothing but the log value. See, how does log value work? Log value works like this. What is n value here? N value is suppose 3. What is log 2 of 8? Okay, means what power if I put of 2, 8 will come. 3, that is the answer. Okay, 3. 3 can be written as log 2 of 8. Okay, that is how the log value works. 2 power something is n value, so what is that power? That is my answer. Okay, so it can be written in the form of log, and t of n, t of 1, until we reach the end it will become 1, because finally it will become n by n, that will become 1. Okay, so t of n is t of 1 plus log 2 of n, and when we keep on going, we'll be getting the final value log 2 of n plus 1, because t of n is a constant which is 1 value. So the number of binary digits will be log 2 of n plus 1. Okay, so this is the time analysis for the binary recursive. Okay, so those two are very important, the recursive and non-recursive mathematical analysis with examples and steps. Okay, moving on, we have selection sort. Okay, we have 4 things left, which is selection sort and bubble sort. Then we have the we have one comparison here, and another one is the binary string comparison. We'll come at that. Okay, so first is selection sort. Okay, so consider an array. Okay, selection sort means we have to sort it in ascending order. Okay, we have to find sort these values in ascending order. In selection sort, what we will do, we'll find out the least value. Which is the least value? 17. That 17 will be exchanged with the first value, because least value should come in the first place, right? So 89 will come here and 17 will come here. Okay, if you trace this, you'll understand. 89, 17, we got the least value, we put 17 here and done. Now next least value will be replaced with 45. We'll find out which is the least value. 29. Replace 29 with 45. Then the replacement starts from here. Least value will be replaced with 68, least value will be replaced with 90, least value will be replaced with 90, and least value will be replaced with here 90, because 90 is the last one, it will be staying at the end. Okay, so we have a sorted array using the selection sort. The code is also very simple. 0 till n minus 2 you are going. We are assuming that the minimum value is present at the ith index, means the first index minimum value is present. Then we'll keep on checking if minimum value more is present or not in this loop. Okay, inner loop. If a of j is less than a of min means j is less than min, means min should be having the j value. So min will become j. After this loop is done, we have the least index. When you get the least index, it will be swapped with the first element. Okay, first element means in this case first. I value will increase, then this will become first. I value will increase, this will become first. Each point of time, I value will indicate which element is to be exchanged, and which is the element to be exchanged, the minimum value which you find in the j loop, right? Minimum value. okay, the j value. So this is how the selection sort algorithm is. Time analysis is also very simple. Two for loops are here, 0 to n minus 2, 0 to n minus 2, and I plus 1 till n minus 1, I plus 1 till n minus 1. When you expand it, I will be getting n minus 1 into n by 2, which is nothing but n square. Okay. Next, the bubble sort. Bubble sort, very simple. Compare these two. If this should be smaller, this should be greater, that should be ideal scenario. If this is not, exchange both of these. So 45 and 89 will be exchanged. Next, 89 and 68 exchange. 69 68 and 89. 89 and 90, is it correct? Yes, it is correct. 89 and 90 should be in the same order. 90 and 29, is it in the same order? No, exchange. 29 and 90. Then 90 and 34. Then 90 and 70. 17 will come here, and we will get 90 at the end. Next, we'll again compare from here. 45, 68, see this one, this one, is it correct or not? And whatever we get at the end, that will be the second largest element. Okay, we'll sequentially keep on checking the next element if it is smaller or greater. Based on that, we'll be making the exchanges, and we'll keep on going. This is algorithm is called as bubble sort algorithm. Okay, now here also the code is similar. 0 to n minus 2, 0 to n minus 2 minus I. Each time we are checking and swapping. Okay, so the time analysis is also very simple here. We are just have to expand these notations here, and we'll multiply it with the n minus 2 value. We'll be getting this value, which is n square here. Okay. The third one is the sequential search. Okay, this one I already discussed. What is sequential search? One by one we'll be searching. Okay, until we get an element, we'll be searching it. If we get, we'll return I, also return minus 1. Okay, this is sequential search. Last one is the brute force string matching. Brute force string matching means, suppose that this is a string here. Nobody noticed him. We have to find out a pattern. What is the pattern? NOT. We'll check if NOT is equal to NOB or not. If it is not correct, we'll move on. We'll check if OBO is equal to NOT or not. If it is not, we'll move, and we'll check BOD is equal or not. Then we'll check ODY. Then we'll check dy underscore. We'll check y underscore n. We'll check underscore no. We'll check not. We got not here. Whenever we get, we'll stop. Okay. How will I implement this one? I loop will run from 0 to n minus m, and j will be 0. Okay, I will run from 0 to n minus m, and j will be 0, while j is less than m, and p of j. P of j means pattern of j. Patterns j is matching with t of I plus j means this value. I is here, I plus j is here. So I plus j, if it is matching, if this value is matching, then we have to do j is equal to j plus 1. Means we'll check these two, then we'll check these two until this ends, means the m value crosses, means this value crosses here, means nothing is left to compare, and all the comparison was successful here. That means you will return I. J is m means it is successful, and will return I. I means where it is found, which index the pattern is starting. Else, if we did not get till the end, we will be returning minus 1. Okay, this is the brute force string matching algorithm. That's all for this video. Don't miss any of these questions. Most important from the exam point of view. And please do like and subscribe. It helps to make more videos like this. And thank you so much for watching. I'll see you in the next one.